Hello everyone. Today I am going to talk about an important part of C programming language, that is the linked list. In simple words, we can consider it as an ordered set of data elements, each element containing a link to the next element. So let's see here. We can consider this block and this block as two data elements. In the definition, I said that there is a link between the data elements. So here is the link. It means that this data element knows the location of the next data element. This is the basic concept about linked list. We can broadly classify linked list into two categories, that is singly linked list. Second one is doubly linked list. Right now I am going to talk about only singly linked list. So what is a singly linked list? In a singly linked list, each data member, also known as a node, contains two parts. First part is called data part. Second part is called a reference part. So the data part basically contains the information and the reference part contains the link to the next node. Technically, you can say that the reference part consists the address of the next node. Apart from the data and reference part, a linked list consists of a pointer which points to the base address of the first node, also known as the head. So let us take an example. The head contains the base address 100, which is also the base address of the first node. Let us consider a number in the data part as 3 and the next address be 200. So the head links the first node. Let us consider a second node with base address 200, data part be 4. So the first node contains the base address of the second node in the reference part. So here is the link again. If we consider that our linked list consists of only two nodes, so the last node reference part should be null, which means that it does not point to anything else. We are going to use a structure for defining the linked list. So we can take the keyword struct. Let us name it as node. We know that a linked list consists of a data part. So here we can take the linked list to hold integer data. So we are writing int data. As for the reference part points to the location of the next node. So it should be a pointer, but its data type should be of struct node type. So we are going to write struct node star next. Here next is the reference part. The data type of next is struct node because it is going to point to the base address of a node. That is why it should be of struct node type. Apart from this, we are going to need a head part. Since it is also a pointer, its data type should be of struct node type. So we can write struct node star head is equal to, now let's see here, since there is no node in the linked list, the head should point to null. Otherwise, if there is a node, it should point to the base address of the first node. Here we have not created any node yet, so the head should point to null. Now you can see that this is the basic structure of a singly linked list. Until now we have seen how to define a singly linked list. Now I am going to show you how to allocate space for a node. For this we are going to need a function named as malloc, which belongs to std.lib.h header file. For allocating space for a node, we are again going to need a pointer of struct node type. So let us take the pointer struct node star p. The syntax will be p is equal to struct node star malloc size of struct node. Now we have to enter the data part and next part. Since we are using a pointer to point to this node, so we are going to use the arrow operator instead of dot operator. So let us enter the data part. It will be p arrow data equal to 3, as we have taken the data part as integer. For the next part, it should point to the address of the next node or null. So here we are taking it as null. P arrow next equal to null. There is still one step left, that is we have to point the head to the base address of the first node. So we can write it like head is equal to p. Head is a pointer, p is also a pointer, so head will hold the address of p, which is also the base address of the first node.